Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about section of the solids. I am Dr. A.I.P. Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a square prism having axis height 90 millimeter, which is resting on its square base onto the horizontal plane, and the edges of the base of the square prism, they happen to be equally inclined with respect to the vertical plane. So if we orient the square prism with respect to the two reference planes in such a way that the square prism is resting onto its base into this orientation, then we will find that two of the edges of the base, they will happen to be parallel to the vertical plane, and two edges of the base, they happen to be perpendicular to the vertical plane. So all the edges of the base, they do not happen to be equally inclined with respect to vertical plane. So this is the incorrect orientation of the square prism onto the horizontal plane. Whereas if we locate the square prism into this orientation on the horizontal plane, now we observe that all the four edges of the base, they happen to be inclined at an angle of 45 degrees with respect to the vertical plane. So this is the correct orientation of the square prism onto the horizontal plane. Now we have been provided with the information that the prism is cut by an auxiliary inclined plane which is perpendicular to the vertical plane and inclined to horizontal plane at a certain angle of inclination, and this auxiliary inclined plane or the cutting plane, it passes through the midpoint of the axis in such a way that the true shape of the cut section happens to be rhombus of maximum length diagonal over here. So in order to obtain true shape of the cut section, which will be obtained as a rhombus, now this cutting plane should be passing through all the four vertical edges of the square prism. So here we have got the base of the prism 1, 2, 3, 4. Then the top face is A, B, C, D. So now the vertical edges, they are A1, B2, C3 and D4 over here. So this cutting plane should be passing through all the vertical edges of the square prism. And then another thing we need to remember over here, that we have to obtain true shape of the cut section as a rhombus having maximum length of the diagonal over there. In order to obtain the true shape of the cut section as a rhombus having maximum edge length over here, so we have to ensure that the cutting plane should be passing through these two extreme points which are lying on the opposite corners of base and the top face over here. That is, the cutting plane should be passing through the point A of the top face which exists on the left hand side, and the corner 3 of the base over here which is just lying opposite to the corner A at the base of this particular square prism. Only then we are going to get the maximum length corresponding to this diagonal over here. And another thing we need to remember over here, because if the cutting plane is going to pass through these 2 points alongside the vertical edges A1 and C3, then whatever rhombus we should be obtaining onto the auxiliary inclined plane which will be drawn parallel to this cutting plane, so onto that auxiliary inclined plane, the auxiliary plan projection view will be represented as a rhombus having maximum edge length over here. Why? Because this edge length, that is joining the points A and 3 of the top face and the bottom face over here. So this will provide us with the maximum edge length corresponding to the major diagonal of this rhombus over here. So this dimension, that is joining A3 points over here, will be represented as the major diagonal of the rhombus, which will be the diagonal of maximum length over here. So this way we have been able to obtain the orientation of this auxiliary inclined plane, as this auxiliary inclined plane passes through the midpoint of the axis over here. So we can check, this is the axis point O available to us at the top face of the solid. This is the axis point O1 which is available with us corresponding to the base of the solid. So once we join these 2 points O and O1 in the front view projections, so point M will be located onto this axis OO1 as the midpoint. And once we join these 2 points A with point 3, so we will find that the cutting plane will be passing through the midpoint of the axis OO1 over here. So now the orientation or the inclination of the auxiliary inclined plane with the horizontal plane can be evaluated in this manner. Now another thing we are required to evaluate into this problem is that we have not been provided with the edge of the base corresponding to the square prism over here. So the edge length of the base has not been provided to us. So how do we evaluate that? Now you see that whenever we are going to project the square base into this orientation onto the horizontal plane in the top view projections, now here we are going to draw the front view projections of the square prism over there. Now when we are going to obtain the true shape of this cut section onto the auxiliary inclined plane, now here the dimension of the minor diagonal of the rhombus has been provided to us as 40 millimeter, because we have been provided with the information that the shorter diagonal of this rhombus happens to be 40 millimeter. So therefore now this shorter diagonal, which will be perpendicular to the major diagonal of the rhombus, so this will measure 40 millimeter. And how these 2 points of the minor diagonal we are going to obtain? So it is this distance, that is the diagonal of the square prism, which will be projected as minor diagonal into the true shape projections over here. So this way one thing is clear, that the length of this edge which is going to join 2 points A and 3 will be represented as a major diagonal in the true shape projections. Similarly, the minor diagonal dimension 40 millimeter, this has been drawn corresponding to these 2 points of the base of the square prism. So now indirectly we have been provided with the diagonal of the square prism over here. So corresponding to the square base, so this diagonal, that is the vertical diagonal and the horizontal diagonal, so both of these diagonals will be equal to 40 millimeter. So this way, even though the edge of the base has not been provided to us, but by providing us with the dimension of the shorter diagonal or the minor diagonal of this rhombus, that is 40 millimeter, so we have been provided with the diagonal of the square prism as 40 millimeter. So using this information, we will be able to draw the square prism into this orientation such that all the 4 edges of the square prism will happen to be inclined at an angle of 45 degree with respect to the vertical plane. So with this information, we are going to determine the inclination of the auxiliary inclined plane or the cutting plane with the horizontal plane, sectional front view and the top view projections, and the true shape of the cut section over here. Now let us first of all proceed with evaluation of top view projections of the square prism when all the edges of the square prism, they happen to be inclined at an angle of 45 degree with respect to the vertical plane. So now the edge length of the square prism has not been provided to us, rather the diagonal BD and AC has been provided to us. So corresponding to this diagonal length 40 millimeter, Now we are going to draw a circular projection onto the top view projections over here. And once we obtain the circular projection, now the two mutually perpendicular diameters we are going to join over here, or we can divide the circle into 4 equal parts. And now these 2 points of the first diagonal and these 2 points of the second diagonal we have been able to obtain. Now having obtained these two diagonals of the square prism, now we can join the points 1, 2, 3, 4 over here, and we can join A, B, C, D points over here. So these diagonals, they correspond to 1, 3 and 2, 4 diagonals of the square prism. Now we can join the edges of the prism. So this way we have been able to plot the projections of the square prism when all the 4 edges of this prism happen to be inclined with respect to VP at an angle of 45 degree over here. So now let us mark the different points. So the top face of the square prism we have marked as A, B, C, D. So these 4 points we have marked on the outer side of the square prism projections over here. Next we have got the points 1, 2, 3, 4 corresponding to the base. So these 4 points we have marked on the inner side of the square projections which we have obtained into the top view projections over here. Now diagonals 1, 3 and 2, 4 we have already joined. So now we will be obtaining the axis points O and O1 into the top view projection. So point O, it corresponds to the axis point corresponding to the top face, whereas the axis point O1, it lies onto the base of the square prism. Now having obtained the axis point and the projections corresponding to the top and the bottom face of the square prism, let us now obtain the front view projections of the square prism. So since we know that the height of the axis is available with us as 90 millimeter. So since the square prism is having axis length is equal to 90 degree, now we have been able to obtain the front view projections of the square prism. So we can see points A dash, B dash, C dash and D dash, they have been obtained corresponding to the top face at a height of 90 millimeter from the XY reference line. Similarly, the base points 1 dash, 2 dash, 3 dash and 4 dash, they have been projected onto the XY reference line over here. And now the axis points O dash and O1 dash, they have been appropriately located onto the top face and the bottom face of the square prism respectively. So one thing here we must remember that this vertical edge D4, it happens to lie on the rear side of the solid. So the projections corresponding to D4 into the front view projections, that is D dash 4 dash, should have been drawn as a dotted line or the hidden line projections over here. But this vertical edge D4 has been coincided with or superimposed by the vertical edge B2 over here into the front view projection. So that is why the object line projections drawn corresponding to the front edge, that is B dash 2 dash over here, so they will be overlapping with the hidden line projections corresponding to the vertical edge D dash 4 dash over here. So that is why we are not able to observe the hidden line projections corresponding to the edge D dash 4 dash and the front view projection. So now having obtained the front view projections and the top view projections corresponding to a square prism which is resting onto its base on the horizontal plane with all the edges of the base equally inclined with respect to the vertical plane. So now we know that this square prism has been cut by an auxiliary inclined plane passing through the midpoint of the axis. So here we have the axis point, that is O dash and O1 dash. So midpoint, it will be lying over here, and another information is available with us that the true shape of the cut section will be appearing as a rhombus having maximum diagonal length over here as major diagonal, and the shorter diagonal will be equal to 40 millimeter. Now here the major diagonal of the rhombus will be represented by 2 points which should be lying onto the vertical edges A-1- and C-3- respectively over here. So when 2 points of intersection we are going to obtain onto these two vertical edges A-1- and C-3-. So accordingly, whatever length of the edge we are going to obtain, which will be corresponding to the 2 points of intersection, which will be obtained corresponding to the auxiliary inclined plane, which is going to cut this solid over here inclined to the horizontal plane. So we can check if we have these 2 points of intersection. Now the edge length will be shorter. If we have 2 points of intersection as these 2 points, so edge length will be increasing. But if we can join the 2 corner points over here, that is this point A with this point 3, that is leftmost corner of the top face with rightmost corner of the bottom face. So if we can join A dash with 3 dash over here, so then we will find that this edge length, which is going to represent the line joining 2 points of intersection which are available onto the vertical edges A-1- and C-3- over here. So this edge length will be the maximum edge length which we are going to obtain. So from point M dash, that is the midpoint, now 2 arcs we have drawn which are going to pass through the points A dash and 3 dash in the front view projections over here. Now this edge length we can check. This is the maximum edge length which is possible corresponding to the cutting plane which is going to intersect with the vertical edges A-1- and C-3-. Let us say we had this edge length, it would have been shorter. Had we got this edge length, it would have been even shorter. So the maximum edge length or the length of the major diagonal will be available with us when we are able to join these 2 opposite corners of the top face and the bottom face over here. So this is how the maximum edge length of the rhombus major diagonal will be obtained into the true shape projections over here. So now we have been able to identify the location and orientation of this auxiliary inclined plane with respect to the horizontal plane, and this angle of inclination will be observed as 45 degree with respect to the horizontal plane because it is passing through the midpoint and it is passing through the 2 extreme points lying on the opposite corners of top face and the base respectively. Now this portion of the solid has been cut and this portion of the solid has been removed. Let us now obtain the 4 points of intersection which are available with us by virtue of intersection of this cutting plane with the square prism over here. So these 4 points we are going to locate in the front view projections as well as into the top view projections over here. Now we can check the vertical edge A-1- has been intersected by the cutting plane at the point A dash, that is at the top of this vertical edge A-1-. So this cutting plane is going to intersect this vertical edge over here. So point 11 dash over here, this is going to coincide with point A dash. Reason? Because the cutting plane passes through the leftmost top corner point A of the square prism. So 11 dash and A dash points, they have coincided with each other. So now when we look at this vertical edge from the top, let us locate the point 11 into the top view projections over here. Now since points A dash, 11 dash and 1 dash, they are lying onto one vertical line and A dash and 11 dash, they are also coinciding with each other. So the top view projections of these 3 points, they will also be coinciding with each other. That is, points A, 1 and 11, they will also be coinciding with each other into the top view projections over here. Now the next point of intersection of the cutting plane with the vertical edge, this one B2. So the cutting plane, it intersects with the vertical edge B dash 2 dash in the front view elevation view at the point 12 dash over here. So this point 12 dash also coincides with midpoint, that is M dash. So 12 dash, it is the point which is lying at the midpoint of the vertical edge B dash 2 dash over here. Now we have located point 12 dash in the front view elevation projections. Now let us locate this point into the top view projection. So once we are going to look at the edge B2 over here, so 12 point will be lying in at the midpoint. So we'll find that points B, 12 and 2. So all 3 of these points, they are going to coincide with each other. Now the third point available over here with us, it is corresponding to the vertical edge C dash 3 dash. This is the vertical edge C dash 3 dash. So we have already observed that cutting plane passes through the base corner point 3 of the square prism over here. So point 13 dash and 3 dash, they are also going to coincide with each other so that we can have the maximum edge length of this particular points of intersection and correspondingly the maximum length of the major diagonal of the rhombus into the true shape projections we will be obtaining over here. So now we have got point 13 dash lying onto the base of the square prism alongside point 3 dash. So now when we look at this vertical edge C dash, 3 dash and 13 dash from the top, so all the 3 points, that is 3, C and 13, they are going to coincide with each other. So point 13 will be obtained alongside the points 3 and C into the top view projection. So the last point of intersection of the cutting plane with the vertical edge, which is D4, which is lying on the rear side of the solid, it happens to be point 14 dash. So we can see that the vertical edge D dash 4 dash has been intersected by the cutting plane at this point 14 dash, and 14 dash coincides with 12 dash and M dash into the front view projections over here. So now the points D dash, 14 dash and 4 dash, they are also lying alongside one vertical projector line perpendicular to the horizontal plane. So the top view projections of these 3 points, again they are going to coincide with each other. So we have obtained points D, 4 and 14 coinciding with each other into the top view projections over here. So now this portion of the solid has been cut by the cutting plane. So now we have been able to obtain the location of all of these 4 points of intersection into the front view projections and the location of all of these 4 points of intersections of the cutting plane with the square prism into the top view projections as well. Let us evaluate which portion of the solid has been removed and what is the remaining solid which is left behind after the sectioning of the square prism by this auxiliary inclined plane. Now we can see this portion of the solid has been removed and this is the remaining portion of the solid which is left with us. Similarly in the top view projections, so this is the portion of the solid which is left behind and it is going to coincide with the sectioned top view or the sectioned apparent projections of the cut section over here. So we can check this cut section 11 dash, 12 dash, 13 dash and 14 dash. So this cut section happens to be inclined with respect to the horizontal plane. So top view projections corresponding to this cut section, it will be appearing as apparent shape projections into the top view projection over here. So that is why the sectional top view projections which we have obtained over here, they are representing the apparent shape projections of this cut section as they are obtained in top view projections over here. So this way we have been able to obtain the sectional front view and the sectional top view projections of the square prism which has been cut by an auxiliary inclined plane passing through the midpoint of the axis in such a way that the true shape of the cut section will be having maximum edge length as its major diagonal over here. Now we are required to obtain the true shape of the cut section. So in order to obtain true shape of the cut section, so we have to draw an auxiliary inclined plane parallel to this cutting plane which has been shown over here. Now parallel to this cut surface or parallel to this cutting plane, we have drawn an auxiliary inclined plane x1 y1 in such a way that this auxiliary inclined plane x1 y1 will be parallel to this cut section, so that whatever projections will be obtained onto this auxiliary inclined plane, that is the auxiliary plan projections we are going to obtain over here. So these auxiliary plan projections, they will be providing us with the true shape of this cut section over here. So from the 4 points 11 dash, 12 dash, 13 dash and 14 dash of the cut section view which we have already obtained over here, so from these 4 points we have drawn the perpendicular projectors onto the AIP x1 y1. Now onto these projectors we are going to obtain the auxiliary plan projections corresponding to this cut surface, and we will observe that the true shape of the cut section will be appearing as a rhombus over here. So let us evaluate location of all these points over here. So the first point available over here is point 11. So we have measured the distance between point 11 and the XY reference plane over here. And then from the projection point 11 dash in the elevation view, now this is the projector that we have drawn. So onto this projector ahead of the plane, the same distance which we had marked corresponding to the point 11 distance from the XY reference plane. So the same distance we are going to mark it out over here. So we will be obtaining the point 11 1 into the plan projection view. Next point available with us, this is point number 12. So again we have measured the distance between point 12 and the XY reference plane. Now from the elevation projection point 12 dash, we have drawn this projector line. So onto this projector line, the same distance as we had measured corresponding to the distance between point 12 and the reference plane XY. So same distance we have marked it out over here. So we obtain the point 12 1 into the plan projection view. Now the next point available with us is point number 14. So the distance of point 14 from the XY reference line we have evaluated. Now from the point 14 dash, so this is the projection line that we have drawn. So onto this projector line, same distance of point 14 from the XY reference line we have plotted over here, and we have been able to obtain the point 14 1 into the plan projection view. And finally, last point available over here corresponding to the section surface, this is point 13. So corresponding to point 13, we have measured the distance between point 13 and the XY reference plane. So corresponding to point 13 dash of the elevation, this is the projector line. So onto this projector line, the same distance of the point 13 from the XY reference line will be marked ahead of the plane x1 y1 over here. So the point 13 1 has been obtained into the auxiliary plan view projection over here. So once we join all of these 4 points 11 1, 12 1, 13 1 and 14 1, so we observe that we have obtained the rhombus projection over here as a true shape projection, and this length 11, 1, 13, 1. This will be equal to the distance between the points A dash and 3 dash over here. So this distance A dash 3 dash will be equal to the distance between the points 11, 1, 13, 1, and the distance between 12, 1 and 14, 1. This is equal to the diagonal distance between the base points of the square prism. So for the square prism, this is the diagonal distance which is equal to 40 millimeter. So we can measure this out. This distance, this is equal to 40 millimeter. So that is why, since these 2 points, they are projected over here. So this diagonal length we had taken in the case of square prism to evaluate the edges of the square prism over here. So this way we have been able to obtain true shape of the cut section by drawing an auxiliary inclined plane parallel to the cut section and obtaining the auxiliary plan projections onto this auxiliary inclined plane over here. So this is all for today. So through this discussion, first of all, we have been able to evaluate the edge of the square prism to begin with. Then we have been able to evaluate the orientation of the auxiliary inclined plane when the cutting plane passes through the midpoint of the square prism, and the true shape of the cut section should be having maximum edge length as a major diagonal when the minor diagonal of the true shape of the cut section, which is a rhombus, had been provided to us. So we will be continuing with further discussion regarding few more illustrative cases of section of the solids in the coming lectures. So thank you very much. Thanks a lot.